So in this video, I'll be talking about how to graph a hyperbola using a conic paper. So the first thing I would like to state is that we should first calculate the distance, or we should first count the distance in between our two foci here. So the distance is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And so since the focal distance is actually going to be 17, this means that the distance in between the median of these two foci and these foci themselves, or each of these foci themselves, needs to be 8 units. Now, to demonstrate this, let's have a set of integers from 1 to 17, so such that it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and finally 17. So we know that from here the midpoint is 9, and so our data here is divided into 2. So since our data is divided into 2, we can see that the distance in between the last number in between each half of our data and the median itself is 8 units. So it's 8 units apart. So like this one over here is 8 units apart from this 9. And so from there, even this 17 over here is also 8 units apart from this 9. So using this reasoning, we can then deduce that from there the distance in between the midpoint in between these two foci and each of these foci themselves needs to be 8 units. So from there we should count round about 8 units. It should be 1, 2, 3, 4, 5, 6, 7, 8. So from there, how many units is this foci away from this midpoint? It's 1, 2, 3, 4, 5, 6, 7, 8. So from there, we are given this condition that PF1 minus PF2, so this PF means point from foci, so it actually means, so that's what it means. It means point from foci. And so it means, so this PF1 means it's a point from foci 1, and then PF2 means it's a point from foci 2. And so another thing that I like to do is that I like to extrapolate an XY plane, or as we would normally call it in Africa, a Cartesian plane. I'd extrapolate a Cartesian plane or an XY plane from this midpoint over here. So from there, after extrapolating an XY plane from this midpoint over here, so this line, we would treat it as our y-axis, and then from there, this line, we would treat it as our x-axis. So we have this such that this is y, and then this is going to be x. And so that's one of the other tricks that I normally like to use. And so from there, to find the vertices of this hyperbola, what we will do is that since we're given this condition of PF1 minus PF2 equals to 10, we divide this 10 by 2. What we'll get is 5. So what does this 5 mean? So this 5 means that the distance in between the midpoint and each of our vertices needs to be 5. So each of our vertices in this hyperbola needs to be 5 units away from this midpoint. So now what we will do is that we will then calculate, or we will then count. So from here, what number is 5 units? So from here we count 5 units away to the left. From here we count 5 units away to the right. And so we do it like that. So 1, 2, 3, 4, 5. So from there, this point over here is our vertex 1, and then from there we count 5 units away even to the right, and so it's going to be 1, 2, 3, 4, 5. So this is going to be our other vertex. So these 2 points are our vertices within this hyperbola. So from here we count, we look for numbers that will meet this condition of PF1 minus PF2. So let us start off by why we used these numbers as our vertices. So if we look from, so this unit, or this point over here, if we can count the distance, we'll find that it's 13 units away from foci 1 and 3 units away from foci 2, and 13 minus 3 equals to 10. So it's such that it meets this condition of PF1 minus PF2 equals to 10. And so from there, let us look for other numbers that will then meet this condition of PF1 minus PF2 equals 10. Let's try, let's say 14, 4. So if we can count the distance from like this foci up to this point over here, so like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'll find that it's 14 units away from foci 1. So from there we mark this circle over here as, I would say, our arc of reference. We mark the arc within the circle over here as like our arc of reference. So it's 14 units away from foci 1, and then from there we count from foci 2. So it's going to be 1, 2, 3, 4. So this is our point. So this point right here is going to be our 14, 4, because again 14 minus 4 equals, so 14 minus 4 equals to 10. And so it meets this condition of PF1 minus PF2 equals 10. Now let's look at other units. 15, 5. So 15, 5 will be, so here it's 15 units away from, it's 15 units away from foci 1. Here it's 5 units away from foci 2. Here it's 16 units away from foci 1. And then it's going to be 6 units away from foci 2, because yet again, if we count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 16 units away from foci 1. And then how many units are away from foci 2? It's 1, 2, 3, 4, 5, 6. And we know that 16 minus 6 equals to 10. So it's such that it meets this condition of PF1 minus PF2 equals to 10. And so from there, we do the same thing to find other points that will be below the x-axis. So from here, this is 14 units away from foci 1, and then 4 units away from foci 2. This is going to be 15 units from foci 1, and then 5 units away from foci 2, and then 16 units from foci 1, and then 6 units from foci 2. And so if we join these points, what we will notice is that we get a branch of a hyperbola. So this is going to end up being the very first branch of our hyperbola. And so in the next video, we'll be continuing with this idea of building up a hyperbola using a conic paper, and hopefully we will finish up this whole idea of building up a hyperbola using a conic paper.